Okay, in this little demonstration we want to look at how to do a blocked ANOVA. So I actually need to reload the data set, so we'll just quickly go through that. Okay, review the data set. If you look at this data set, this is the lichen 4 data. It's got the 4 sides of the trees and the lichen amount, but it also has, in the first column here, an identifier for each tree, and you'll see that that goes from 1 to 10 and then repeats 1 to 10. So this represents the situation where for each tree we have each of the 4 faces measured. Okay, they're sorted here by side, not by tree, but that doesn't really matter as far as the stats is concerned. Alright, so it's different from the paired t-test. Well, the test that we're doing is similar to a paired t-test. Remember that in a paired t-test we had to have one column for the first observation in the pair and another column for the second observation in the pair. And here we don't have that. Alright, how do we do the test? We go basically to statistics, means, and you'll see that in this version of RCommander there is a blocked ANOVA. Okay, this will only occur if you're using the UWS version of RCommander. We go to blocked ANOVA. Now here in this dialog we've got to choose the response variable. There's only one sensible variable for the response. It has to be numeric, so that can only be lichen in this data set, and that's already selected for us. We choose the grouping variable and the blocking factor. So for us the grouping variable is the side. That's the thing that we're primarily interested in. The blocking factor is then the tree. It forms the blocks. Each tree is a separate block, and we measure that for 4 of the sides, and they're like our treatments. Okay, that's all we have to do, so then we click OK. Now down the bottom there's rather a large amount of output for this particular analysis, and in fact the interesting part's scrolled off the top. So if I scroll back down, we get back down to the ANOVA table. Alright. So here we have the ANOVA table. Okay, it talks about type 2 tests. You don't need to worry about that for this unit. It tells us that the response is lichen. And we have the sums of squares and the degrees of freedom in the other order than the previous ANOVA table, and in the other order than we used in lectures, but that doesn't really matter either. So the sums of squares comes first, you can see it's written there, and the degrees of freedom. So we have a sum of squares for the side, which is in this case the factor of interest or the treatment. We have a sum of squares for the tree, which is our blocking factor, and we have a sum of squares for residuals. In lectures we called residuals error, but here it's the same thing. Then we have the degrees of freedom. We have the degrees of freedom for the side, the degrees of freedom for the blocking factor tree, and the degrees of freedom for the residual. And then we have 2 lots of f values. We have f value for the side and an f value for the tree. So in this particular table it doesn't list the mean squares, it just actually goes straight to the f values. Okay. And the final part is the p-value. So the p-value for the side is 0.01991. Okay, so that's significant at the 5% level, but not at the 1% level. And under that you see there's an actual p-value for the blocking factor, the tree. Okay, there is some debate as to whether that's actually useful or not, but here it's been given and it's quite small, so there really is a difference amongst the trees if we're prepared to believe that. Okay, then underneath there is a table of means for each of the combinations of tree and side. Now in this data set, because we're talking about the simplest possible type of blocked data, each tree side combination only occurs once, and so that mean is actually the observation, so that table's less useful for us. I'll just explain the other 2 tables below that. One of them is the standard deviations, and again, because there's only one observation per combination, you cannot calculate a standard deviation, so that's labelled as not available, or NA for short, in this data. And then the last little table are just the counts of the numbers of each combination of tree and side. And you can see that that's 1 here for all possible combinations, which is the simplest possible way that this data can be set up. As we briefly mentioned in lectures, of course, it doesn't have to be 1. The software can do this analysis for all sorts of combinations, but we really only talk about the case where there's 1 treatment for each blocking factor. Okay, that's the end of this demonstration.